Hey guys, thanks for taking the time to respond to this feedback. And I don't want to sound harsh, but I have, so sometimes I come off like a know-it-all. I hope that that doesn't happen here. But I have been teaching honors algebra 2 and honors geometry for over 20 years, and have a really good feel for what's going on, logistically in a classroom, and what makes for the most effective yet challenging lesson. So I want to start with a warm-up first, because I think that's absolutely crucial. And my warm-up, let's see here, let's actually open that up. And the reasoning behind my particular warm-up here versus the one that AoPS gave. So here's a warm-up that I actually did on the Thursday night class. And this warm-up, and again, it says, well, make sure not to spend more than 5 minutes on it. And I can honestly say no kid understood this. And we have some really smart kids in class. But also the thing that really is, I think, bad about this, while it's super interesting to me, as far as for these 11, 12, and 13-year-olds, is they're coming in for the class. They're settling in and, like, hey, what'd you do? And, so... this is not a good thing to get them working. And I found this out from years of teaching. You want to get something they can just get right down and get to work, get in that mindset of like, hey, let's get to work. And so this was pretty much impossible to adequately cover in that 5 minutes. Okay. So let me also jump. I'm going to go here. And this goes into the lesson, and then in stark contrast to say this problem, which was way too easy. Okay, and so it wasn't of huge value because everyone knew it. And then this one, which was of value, but I decided to kind of do a little combination here and talk about piecewise functions. So here's what I did. Here, let's go all the way here. Okay, so this was my warm-up question, and notice that there's two questions here. But the first one was about, it talks about, because our last class was on functions and domain and range and inverses. So just reconnect back with what we did the previous week. And this was a challenging problem for some kids. They, so what the heck does that mean? How do I do that? Okay. And some kids did know how to do it. So this is a great way for kids to come in, start working right away, and actually in conversing with each other about a problem that some kids do know how to do and some kids don't. Write the function in slope-intercept form for that linear function. Again, this is something that we want out of them. Anyway, when we start defining our piecewise, as you see here in number 2, and then find the inverse, and that's just kind of a nod to last week. I like to, math doesn't just go away, so I wanted to make sure that they had a little practice with that too. So, we did this first, and we just, go through that problem. So this one is define the piecewise function. And again, there's some kids who understood piecewise functions, but then didn't know how to actually define them. So they tried their own different ways, but there are a lot of kids that didn't know it. So there's kids that their algebra, and it's been from algebra 1 and, past geometry to now. So a lot of kids may have learned it, but forgot. But a lot of kids that maybe didn't take the AoPS algebra 1 didn't know it, had never seen it, and had no idea about it. So it was very valuable to go through and really kind of define how this all works. So also, how to write it out and how we want it, and our domain over here. And again, this gives opportunity to talk about stuff like this. Why is it included in one and not in the other? So again, kind of important stuff. But also, in defining this linearly, pretty easy to find with, a y-intercept. But how about for this? And this kind of goes back to our question 1. Well, now they have that idea of that input-output for, say, this down here, right? Input of 6, output of 3. And I want to carry that idea over when we start talking about transformations as well. So anyway, went through and defined this, and then defined the domain and range. And this was actually very interesting too, because some students didn't understand why we included that when this, and so that that was good discussion too. So anyway, went through that. It did take more than 5 minutes, and I think this was a good 10 minutes altogether. But really, everyone's down and everyone's working and talking, and they're really focused, because it's very approachable for everybody as well. Okay, so I did this a little bit differently. Not really important. We played a match game with this, so this was kind of a fun way to do it. So went into transformations and just made a real quick connection with what they've learned in geometry, and how we'll be talking about translations, reflections, and dilations as far as scaling. But I did something that we did that AoPS didn't do, was talk about transformation parameters, and I think this is really important for these lessons. We'll kind of talk about why. So what I did is I came back to this one that we've already defined, and as opposed to here, let's go here. Okay, so after this game, we went to here. Okay, so this was something new that they didn't have to actually define. We just started jumping right in and talk about what's happening here. Okay, so that's really basically what we did here, but I just gave them this function and I said, now, write that one, which is not hard given what we had. But then I just asked them to notice certain things about, the output and what's happening. It's the exact same as f of x, except everything is +4. So when we came to the next step here, and so what happens, it's just here. And that's, that's not much different than AoPS at all. But the one thing that I did do is now I came back and did, this other side. And again, that's not really a hard, those aren't hard dots to connect, except in AoPS, we went from here, right into horizontal. So we went from a vertical translation to a horizontal translation, and this horizontal translation is a tough one for kids, really tough. I can tell you from a lot of experience. So anyway, coming back to here, we did this, and very easily kids recognize that that's just a -3, and so we wanted to generalize. So if we wanted to move it up or down, what would we have to do? Okay, so in that case, there's just some number, and that just tells you whether you go up or down. And so this is the vertical translations parameter. And I know this K here, which is not, we don't mention this, but I know it's mentioned in every textbook in our school district here and some of the other school districts that the kids come from. So I went ahead and labeled it because I know it's something that'll be valuable for them in their academic side as well. At this point, then I did take this and I did label these points because I do want to talk a little bit about point translations and transformations. And so now when I slide this over here, we went to went through this point here, and then there's we said, well, what's happening here? Well, the other one was vertical, up or down, and we'll just say this was horizontal by 3, and I just attached this H here, which of course they see, and we went positive in this. And so, how are we going to describe that? So we did a certain thing. So we end up discovering that this is what happens, how this happens. So really, because we moved it 3, isn't that just x minus whatever that was? We again, talk that through. So what happens with the next one over here? And the thing is, because we didn't do that here, we went the vertical to horizontal, then we jumped right into this problem. And again, for Thursday, that's just a really tough jump for these guys. Okay, so here now once we see this and people recognize that's a horizontal, but now it's going back to, and we worked out how you can logically reason this out. But so now we have this. We still have that x minus, and so again, assigning these, and give this the hook that they can attach the knowledge to, I think is important. Talking about those parameters. That's just me. So then the next thing, we went ahead and then combined them, and I think this is absolutely vital to do that because this is not just instinctual for all these kids. So we went ahead and did this, and then how to write that, instead of just jumping straight into from here to here. Okay, so we did this, and then we came over and talked about this, and let me just show you this real quick. And I made a whole Desmos thing here that showed how that worked. So anyway, and we went through all this, okay, and showed that that's what this shift graph by 5 units, and that's that -5 anyway. So. Okay, so then went back just like we did on Thursday. Okay, I came back here, and of course this scaling. But notice our scaling here, our vertical scaling. Okay, then we go to here, the vertical scaling, which is all good, but I did it slightly different. I gave him this one, what's this? And then, we went to this, but again, I define the scale factor, which again is not defined there, and talks about, this idea here, and then what happens if it's negative. No surprise, kids get that pretty quickly, right? It's a reflection. Okay, this is always really hard for them. So, jump in here and do this one. And I defined it again here, this horizontal scaling and reflection here. And then went to here, this reflect across here. Then what happened from here, though, after we, when this was negative, then we have a couple of practices, chance to put a couple of our transformations together. So we did this one, which is a translation and a compression. Then we do this one, which is a reflection and a horizontal and vertical translation or transformation, I beg your pardon. And then finally this one, again, where we put them all three together. And these are all just doing a couple at a time. And I think they really have to have that intermediate separate sort of thing, because what we did in the AoPS one on Thursday got to a point where we just showed this reflection and then this reflection here, and then went right straight into this. And I can't tell you, this was unapproachable for our guys, because this was way too complex to just go from, and remember, in the AoPS, there has been no combination of transformations at this point, and all of a sudden we just throw the book at them. And nobody could get it. And this was Thursday, so I think that we have to transition better from from our concepts from here. Now start building in two transformations where we're reflecting and scaling and translating. So anyway, yeah, that's just some of my feedback. I tried to make this short, so hopefully I can fit this. But anyway, if you have any questions, don't be afraid to shoot back, because I can add on to this. I just want to keep it short. Bye.